Hello viewers, in today's session we are going to discuss another important and conceptual problem from integrals. And in this class we are going to evaluate this integral with the help of the concept of beta and gamma functions, right? So here we have to evaluate this integral that is from minus infinity to infinity, and the integrand is x square divided by a cube of 3x square plus 1, and we have dx, right? So let us call this integral as I. And here first of all I will apply an important property of definite integrals, which says that if we have an integral that is from minus a to plus a, and we have the integrand f of x and dx, then if this function f of x is an even function, then we can write this integral as 2 times the integral from 0 to a f of x dx. So this is an important property of definite integrals, where we can simplify this integral minus a to a fx dx is equal to 2 times integral from 0 to a f of x dx, provided f of x is an even function, right? And in case of odd function, this integral reduces to 0, right? So even function is defined as f of minus x is equal to f of x, right? So here if we compare this integral with this one, then the limits are from minus a to a, that is minus infinity to infinity. For a we have infinity, and the function or the integrand f of x is x square over 3x square plus 1 cube, right? And this function is an even function, which we can see easily by replacing x by minus x. So f of minus x is given by minus x square, and here we have 3 times minus x square plus 1, and here we have cube. So minus x square is a positive x square, and here also we have positive x square, so this is 3x square plus 1 cube, and this is our function f of x. So we have seen that f of minus x is equal to f of x, so this function is an even function, right? So now this integral I can now be written as 2 times the integral from 0 to infinity, that is 0 to a, and f of x is x square over 3x square plus 1 cube, right? And now we'll apply the method of substitution. So let us substitute here t is equal to 3x square, so that using this substitution we can reduce this integral into the beta function, that is beta m comma n is given by the integral 0 to infinity t raised to m minus 1 over 1 plus t raised to m plus n dt, right? So the beta function is defined by this integral where m and n are greater than 0. So using this substitution will reduce this integral into this form. So now we can write x square is equal to t over 3. So x is square root of t over square root of 3. So let us differentiate x with respect to t. So dx over dt is equal to 1 over root 3, and the derivative of square root of t. So we have 1 over root 3, and the derivative of square root of t with respect to t is 1 over 2 times square root of t. So now we have dx over dt is equal to this expression. So now dx can be written as 1 over 2 root 3, and we have dt over square root of t. Now here the limits of integration vary from 0 to infinity. So when x is equal to 0, which is the lower limit, so the value of t can be obtained from this relation. So we have 3 times 0 square, that is 0. And when x tends to infinity, then t also tends to infinity, because here we have 3 times infinity square, that is also tending to infinity, right? So now we can write this integral I as 0 to infinity. The limits remains the same, that is 0 to infinity and 0 to infinity. For x square, we can write t over 3, and here we have 3x square is equal to t, so we have t plus 1 cube, and dt is replaced, dx is replaced by 1 over 2 root 3, and dt over square root of t. So now let us simplify it. So we have I is equal to this 2 and this 2 get cancelled. So we can now write 1 over 3 root 3 outside the integral. So we have 1 over 3 root 3. Then we have 0 to infinity. Then here we have t raised to 1. And here we have t raised to half. And taking t raised to half to the numerator, we can apply the laws of exponent. So this is t raised to 1 minus half, and here we have 1 plus t cube, and this is dt. So we have 1 over 3 root 3, 0 to infinity, and t raised to half, 1 minus half is half, and 1 plus t raised to 3 dt. So now let us compare this integral with this one, right? So here we have t raised to half, and here we have m minus 1. So let us write m minus 1 is equal to half, and here we have 3, and here m plus n is equal to 3, right? So we can now find out the values of m and n. So m is given by half plus 1, that is 3 by 2, and n is given by 3 minus m, that is 3 minus 3 by 2, that is 3 by 2, right? So now we can write the integral I as 0 to infinity, and t raised to half is m minus 1, that is 1 over 2 is m minus 1, and m is 3 by 2. So we can now write t raised to 3 by 2 minus 1, and here we have 1 plus t raised to 3. Now 3 is equal to m plus n, right? Because we want to, or we wish to write this integral in this form. So 3 can be replaced by m plus n. M is 3 by 2 and n is 3 by 2. And here we have dt. So 3 by 2 minus 1 is half, and 3 by 2 plus 3 by 2 is equal to 3. So now we have 1 over 3 root 3, and this integral is our beta function. So we can write beta m comma n, and m is 3 by 2 and n is also 3 by 2. Now let us find out the value of this expression. So for finding out this the value of this beta function, we'll use this result, that is beta m comma n is given by gamma m multiplied with gamma n divided by the sum of m plus n, that is gamma m plus n, right? So here we can now write 1 over 3 root 3, and then we have gamma 3 by 2, gamma 3 by 2, and in the denominator we have gamma 3 by 2 plus 3 by 2, right? So now I is equal to 1 over 3 root 3, gamma 3 by 2 square, because here both these terms are equal, and in the denominator we have gamma 3 plus 3 6 6 over 2, is 3, right? Now gamma 3 by 2 is equal to half times square root of pi, right? And gamma 3 can be written as 2 factorial, that is 2 times 1 is equal to 2. So here we have used this result, that is gamma n plus 1 is equal to n factorial, right? So here we have gamma 3. So gamma 3 can be written as 2 plus 1, that is equal to 2 factorial, that is 2, right? And gamma 3 by 2 is equal to half times square root of pi. So we can now write 1 over 3 root 3, and here we have 1 over 2 root pi square, and gamma 3 is equal to 2. So now I is equal to 1 over 3 root 3, and here we have 1 over 4 pi, and here we have 2. So simplifying this, we have pi over 4 times 2 is 8, 8 times 3 is 24. So we have 24 root 3. So the value of this integral is given by pi over 24 times square root of 3. Hello viewers, in today's session we are going to discuss another important problem from the concept of beta and gamma functions. And in this class we are going to discuss this integral where we have the limits from 0 to 1, and the integrand is 1 minus x raised to 1 by 4 raised to 7, right? So here we'll solve this integral with the help of the definition of beta function, and then making use of some important results from beta and gamma functions, right? So let us first use the concept of integration by substitution method. So let us first call this integral as I, and here we'll convert this integral into the beta function, which is m comma n is equal to the integral 0 to 1, and we have t raised to m minus 1, 1 minus t raised to n minus 1 dt, where m and n are greater than 0. So let us make this substitution, that is t is equal to x raised to 1 over 4, and from this expression we can write t raised to 4 is equal to x, right? Okay, now if we differentiate both sides with respect to t, then dx over dt is given by d by dt of t raised to 4, and the derivative of t raised to 4 with respect to t is 4t cube, and dx is now equal to 4t cube dt, right? Now here the limits of integration vary from x is equal to 0 to x is equal to 1. So when x is equal to 0, then the value of t is 0 raised to 1 by 4, that is simply 0. And when x is 1, then the value of t is 1 raised to 1 over 4, that is equal to 1, right? So now this integral I can be written in terms of t as 0 to 1, and we have 1 minus t, because x raised to 1 over 4 is assumed to be equal to t, and we have here the power 7, and for dx we can write 4 t cube dt. Now we can take this 4 outside the integral, being a constant, so we can now write 0 to 1, and then we have t cube and 1 minus t raised to 7 and dt. Now let us write this integral as t raised to 3. Here 3 can be written as 4 minus 1. because here we have m minus 1. So we can write 4 minus 1, that is equal to 3, and then we have 1 minus t raised to 7, and 7 can be written as 8 minus 1, and here we have dt. So now this integral is given by the beta function. So we have 4 times the beta function m comma n, and m is equal to 4 and n is equal to 8. So we have 4 comma 8. So now let us find out the value of beta 4 comma 8 by using this important result, that is beta m comma n is given by gamma m times gamma n divided by gamma m plus n, right? So here we can now write 4 times gamma 4, then we have gamma 8, and we have gamma of 4 plus 8. So we can now write 4 times gamma 4, gamma 8, and then we have gamma of 12, right? So now we have to find out the values of gamma 4, gamma 8, and gamma 12. So we'll make use of this result, that is gamma n plus 1 is given by n factorial, right? So gamma 4 can be written as gamma 3 plus 1, that is equal to 3 factorial. Gamma 8 is equal to gamma 7 plus 1, that is 7 factorial, and gamma 12 can be written as gamma 11 plus 1, that is 11 factorial. So now we can write this integral I as 4 times 3 factorial, then we have 7 factorial divided by 11 factorial. So now we can write 3 factorial is simply 3 times 2 times 1, that is 6, and here we have 7 factorial. Let us write 11 factorial as 11 times 10 times 9 times 8 times 7 factorial. So here 7 factorial and 7 factorial get cancelled, and here we can now cancel this 8 by 2. Then we have 2 times 3 is 6, then we have 3 times 3 is 9. So we have now a 1 over 11 times 10 times 3, and this is equal to 1 over 330, right? So the value of this integral I is equal to 1 divided by 330.